السلام عليكم ورحمة الله وبركاته. I am Rian Khaled Mashaabi, and now I will talk about functional magnetic resonance imaging. In the beginning, the functional magnetic resonance imaging, or fMRI, is a type of neural imaging used to obtain images of brain activity. Since its inception in 1990, fMRI has been used in an exceptionally large number of studies in the cognitive neurosciences, clinical psychiatry, psychology, and pre-surgical planning. fMRI involves exposing the brain to multiple magnetic fields and relies on the observation that protons in the nuclei of hydrogen atoms respond to this procedure by emitting electromagnetic signals that can be detected by the fMRI scanner. The fMRI scanner is capable of determining some of the properties of the tissue that the signal came from and can use the information to reconstruct a high-resolution image of the brain. The fMRI scanner can detect differences and the magnetic properties of oxygenated versus unoxygenated blood, and this can identify levels of change in oxygen in blood in different regions of the brain by using a method called blood oxygen level dependent, or bold contrast. Bold contrast is typically what enables us to identify which brain areas are most active in fMRI. Areas of the brain that are more active tend to receive higher levels of oxygenated blood. Thus, higher levels of oxygenated blood in a particular brain region are believed to correspond to higher neural activity in that region. On a typical fMRI all-right image, color coding is used to represent differences in the level of oxygenated blood and those differences in activity. Activeness areas are then be associated with whatever task was performed at the time of the scan. A primary strength of fMRI is its relatively high spatial resolution and the availability for both clinical and academic researchers. Also, it is non-invasive, doesn't require injection, and provide high-resolution anatomic scans in the same session. The weakness of fMRI, low temporal resolution, signal dropout, and spatial distortion, trade-off of signal noise ratio and magnetically uniform brain regions. The scanner's loud noise is associated with switched magnetic fields. Also, the high magnetic fields require customized stimulus delivery and subject response systems, again limiting flexibility and complicating multimodal experiments. In conclusion, fMRI was developed in the early 1990s and since has become a very popular neuroimaging method. Nevertheless, in its short history, fMRI research has been plagued by issues like small sample sizes, the use of methods that lead to a high number of false positives, and a small proportion of study results that have been independently reproduced. As the field has become more aware of these problems, many researchers have begun to adjust their approaches to address them. Thank you for listening.